Morning. Today I'm going to talk to you about batteries. I have two kinds of batteries here, although technically I have three kinds of batteries because in one of these boxes around here I have I have alkaline batteries. But I'm going to talk about rechargeables, and I have two flavors of rechargeables. I have the nickel metal hydride rechargeables, and I have lithium ion polymer batteries that are also rechargeable. the uh, nickel metal hydride batteries that I have are these Panasonic NiLoops, which are the best nickel metal hydride batteries on the market today. So I went ahead and bought the NiLoops off of Amazon. And I have two sizes. I have AAAs and I have AA's. And the both of these batteries, the battery sizes, are 1.2 volt batteries. The difference is that the AAAs, like this one, hold 750 milliamps of charge, whereas the larger ones, the AA's, hold 1900 milliamp hours of charge. The disadvantage of nickel metal hydride batteries is that they can develop a memory, and you have to use them frequently or have a charger that can basically refresh the batteries so that they don't develop a memory, or that you can put the full charge in. And the disadvantage there is that these chargers are relatively expensive. So this one is a C9000, and the C9000 is about $100 for the charger. The nice thing about it is that it has this nice LCD display that's backlit. It can handle both the AA's and the AAA size batteries. It has multiple modes so that you can just do a straight charge like I'm doing right now if you've used the batteries recently and just need to top off the batteries, or it can do a refresh and analyze, which is a full charge, a full discharge, and then another full charge, which then displays the full amount of the charge that you can put in that particular cell. So the batteries that I have in here right now are being charged at 295 milliamp hours. They currently have 1.35 volts of voltage in them, and they've been going for 5 minutes. The batteries themselves are not cheap, but when you consider that you can recharge them and reuse them, they're considerably cheaper than AA alkalines or AAA alkalines over time. That, and to be green about it, you're not throwing the alkaline batteries in the landfill. I also have this 9 volt nickel metal hydride battery that I have to use a different charger on because my charger only does AA's and AAA's. The other thing that I have here are these lithium ion polymer batteries. Most of these are from Adafruit. This is a 4400 amp hour battery, milliamp hour battery. This is a 2200 milliamp hour battery. This is a 2500 milliamp hour battery. This over here is a 1200. This is another 2500 milliamp hour battery, but this one's from China. And I had to solder on the JST connector for the Chinese battery. Now, I mentioned this in another video, but these Chinese lithium polymer or LiPo batteries were actually sent to me illegally. They were labeled USB adapter, which clearly they're not a USB adapter. They're LiPo batteries, and the problem is that if you mishandle one of these batteries, it will violently disassemble itself. If you'd like to see what I'm talking about there, you can go on YouTube and just search for LiPo, L-I-P-O, space explosion, and you'll see some very interesting stuff. It's pretty entertaining, although I wouldn't recommend trying it. So, in order to protect these batteries, they have this circuitry in the end, and if I tore this Kevlar tape off, you'd be able to see the actual electronics. So they have protection against overcharging, protection against undercharging or over discharging, and you have to not puncture them. You have to keep them cool so that they don't overheat, because overheating is actually abusing the battery and they can explode. So they're actually kind of sensitive, and that's the reason that it makes me very uncomfortable that these were sent in the regular post, because the U.S. Postal Service won't actually carry LiPo batteries. They have to be sent UPS, and they have to be sent ground. And UPS has restrictions on the number of LiPo batteries cells that they'll actually send in one particular package. The other restriction is that they have to be sent with a device that can use them, or in the device that will actually use them. So if these batteries had exploded in transit, the vendor would have been in a lot of trouble, and there's some question or debate as to whether I would have been in trouble for buying them and having them sent, even though I didn't have an option to send them another way. It's questionable as to how much liability I would have had for illegally importing these LiPo batteries. So my solution is that I'm just going to buy my LiPo batteries from Adafruit and not worry about the Chinese import. Because it's getting difficult to ship these LiPo batteries. First of all, I'm stocking up on them, so I have quite a pile of LiPo batteries over here. The other thing is that Lady Ada, Lamore Freed, recommended was to actually use a battery pack for these nickel metal hydride batteries. So this battery pack has 3 AAA nickel metal hydride batteries in them, or in it, and now I can't close it. There we go. It has an on-off switch, and it has a JST connector so that it will run the electronics that normally run off of a LiPo battery. So this is an Adafruit Feather. It's a 32U4, I think it's a Bluetooth device, Bluetooth Low Energy, and it has this OLED display on it. Now I have it hooked up to a this little sensor that is a high accuracy barometric pressure and temperature sensor. So the display is the current temperature in the bedroom, which is 72 degrees Fahrenheit, and the pressure outside, which is 10,090 pascals thereabouts, or about 1,000 millibars. And the battery voltage is 4.12 volts. And I just started this at 5:30 this morning, and it's 9:30 now. So this battery pack has been driving this device for 4 hours, and I expect it to run for about another 10 hours before it needs to be recharged. But this is sort of an experiment to find out how well the nickel metal hydride batteries perform as opposed to the LiPos. So once I've depleted this battery and this display starts to die, I'll note the time, recharge the batteries, and attach this LiPo to it, and we'll see how long it runs on the LiPo. Do the conversion so that the comparison is like for like as far as milliamp hours goes, and see how well the performance is and the charge time is. So I'm in the charger now. I have completely depleted. Well, I have nickel metal hydride batteries that can no longer drive this device. So once I have those recharged, I'll be able to measure the recharge time. Now this is the LiPo recharger. What you do is you plug it into a USB mini plug the other end into either a battery pack, like this 50,000 milliamp hour battery pack from China, which is actually kind of a nice design. It has this has a LCD or LED display that tells you how much power there is in it, and has the 2 USB outputs. You can plug it into the battery pack. You can plug it into your laptop. You can plug it into a charging device like an Anker charger, and then you plug the battery in where it says battery. And the charge light comes on yellow, and when it's done, it turns green. This is very inexpensive. I don't remember how much this particular charger cost. I want to say it was around $10. It might have been $9.95, but it might have been $15. I don't remember which. The other nice thing about this one is that if you can see it here, there's this resistor called therm, and that's for a thermistor. And so you can actually remove this resistor and put a thermistor on and attach it to the battery pack that you're recharging, and it will make sure that the battery pack doesn't get too hot. The reason that exists is you can use these for solar charging, and that means that your batteries are out in the sun, or at least near the sun where it's hot, and you definitely don't want to overheat a LiPo battery. So the charger will actually cut itself out if the battery gets too hot. The other thing about this particular charger is that it will charge at basically a trickle rate, because it doesn't know the milliamp capacity of the battery that you've attached, it charges at a fairly low rate, which is, I believe, 100 milliamps. So it actually basically trickle charges the battery pack. It takes a little while longer, but you reduce the risk of blowing up one of your batteries. So that's my talk on batteries. The only other thing that I wanted to say is that these nice handsome battery charger or battery holders that I have, I 3D printed with translucent red PLA, and they do a nice job of holding my batteries. Really happy with the designs that I got off of Thingiverse. So that's it about batteries. If you have questions, feel free to let me know, or put them in the comments and I'll answer them. And next time I will probably talk about something more interesting than batteries, maybe clocks or sensors or Arduinos. That's what I'll do. I'll talk about Arduinos next time. Thanks a lot. Be sure to like and subscribe if you're interested. Take care.